MTD CNC, bringing you the latest engineering news, reviews, events and special offers via video media.
Dan, I'm interested in what the ROMER Absolute Arm does.
Okay, ROMER Absolute Arm's portable CMM, so you can take this to your job as opposed to kind of taking your job to the CMM, so you can save on time, but primarily it's for inspection, reverse engineering, rapid prototyping, wind tunnel analysis, that type of thing really.
Okay, so how does it actually work? When we talk about it being portable, how do you get the data from this to the PC? How does all that work?
There's a couple of wires, mainly an Ethernet wire if you're scanning and a USB wire if you're probing, but you can do all that wirelessly. So in short, you've got a range of encoders on your arm that work through triangulation to create a point. So points can be turned into features. Features that are then compared to CAD models or anything like that. Alternatively, you can use a laser head and you can collect lines of points which then become point cloud. So on a line of points you may have 1,000 points, but this will capture at 250,000 points a second. So as you're going along, you're getting a hell of a lot of data, which formulates a very, very basic 3D model to start with.
Okay, so you can use this for reverse engineering as well?
Yeah. You can take this to a complete CAD model, if you like, but at the first point you'll capture an STL, which is a triangulated point cloud. Once you've got a triangulated point cloud, you can put NURBS patches on it, and a surface on it, and then you will get a dumb solid. Alternatively, you can take that, it's what's called an STL, and you can take that into a rapid prototyping 3D printing machine, or you can take that into just basic CAD and start to build up a parametric model from it.
So what's the target audience for this? Who would buy this type of product?
It's a massive range, to be honest. Anybody from the automotive industry, aerospace, heritage. We've got them in dental. We've got them in people like the particle accelerator at CERN. They use things like this and some of our other equipment.
And the accuracy, what you can achieve from what you're measuring?
Depending on the size of the arm, because the bigger you go with an arm, the more potential error you have within its sphere. So a small arm, probably something like a 2 metre arm, you will get around 20 microns. A large 4.5 metre arm, you're probably talking around 120 microns. But that's worst case error within its sphere. Scanning is a little bit less accurate because you're just collecting more data, so there's more potential error. But again, if you're working in a smaller environment, you will get better accuracies. Just like it's a classic static CMM, you have a cumulative error. Within a working sphere of an arm, you tend to have a radial error, where as you go further out, you can potentially cause more error.
Okay, Dan, let's see a demo.
Okay, great. I'll just turn it on to scan, and then we'll go from there. So all I've got on screen at the moment is a scan that I've taken earlier and turned that into a mesh. So I've used that as a reference object, so that would be like the CAD model. So I'm not sure whether you can see, but I've got basically two lines here. Now that red line on here, will, as I go across the surface, it will pick up a point cloud and generate points. Once I've got a load of points, I'll be able to compare those to the reference object, which would be like comparing to a CAD model. So all what's happening on screen now is we're capturing lots and lots of points, which you can see the point counter in the top left hand. Once I've got a near enough replica, I'll compare the two to each other.
So it doesn't matter which order you do this in?
Not at all. You can be fully kind of flexible with how you scan.
And even if you went back over a previous surface, would it pick up that you're doing that?
Yeah, it would pick it up, but it doesn't matter. The software will actually filter out points on top of points. You can clean points out once you've got a point cloud. But as you can see now, I'm scanning over the top of points, but it doesn't matter. It doesn't create a thickness. It just creates another point on top, and then once we're finished, it can clean those all up.
Because I can see you got some blank areas, and that's what you're trying to fill in.
That's exactly it. Yeah, it's just like colouring in. Capture as much data as you can in the areas where you've got little holes. Just go over them and fill them in more.
So what are we going to do now? Have a look at the results.
Yeah, basically, all as we've got now is we've got the reference, as I've said, and we've got the point cloud. So now we're just going to stitch those two together. It's an automatic stitch, one button, and once those two are stitched together, we're going to put a colour map on, which will show a deviation from the reference object, which would be like your CAD model, to the part. So this could be in a batch of 100 parts, and you're comparing each one of those to their master CAD file.
We've got a part for a vehicle here, but it wouldn't matter what the part is, would it? It could be a tool from a tool maker. You could then reverse engineer.
Yeah, not at all. Absolutely anything really. As long as you can get line of sight from your laser to your part, then you can scan anything you want. Anything from rubbers, foams, gloss parts. This laser will cope with absolutely anything, from chromes to matte whites to anything in between. The only things you won't be able to scan yet, unfortunately, are very translucent material and waters. At the moment, still not quite there, but we will get there one day.
So everything else?
Everything else, yeah.
Brilliant. Dan, thank you very much. Fantastic insight.
No problem. Thanks for your time.
For more videos, products and news, go to mtdcnc.com or follow MTD Online on Twitter.